So you guys can hear me, right? Give me a thumbs up. Okay, great. I just want to make sure I didn't mute myself too. So welcome to the November general meeting of the Kalamazoo Astronomical Society. We do have a special guest speaker tonight. We did meet in person before, but he does not remember who I am at all, but I don't blame him. That's fine. I don't take it personally. So tonight's guest speaker first presented to us in January of 2002. Or 2012. And in fact, he was our first remote speaker. So we kind of come full circle here. He has been a contributing editor at Sky and Telescope magazine for the past 7 years. He is the author of the RSpec software, which received the S&T Hot Product Award in 2011. He is a popular speaker who has spoken to hundreds of clubs via the web and in person at many conferences, including NEAF, where we met, and he doesn't remember, the NEAF Imaging Conference, the Winter Star Party, the Advanced Imaging Conference, and others. So without further ado, please welcome Mr. Tom Field.
Thanks, Richard. You can hear me okay?
Yes, we can.
Great, thanks. Good evening, everybody, and thank you for inviting me to speak tonight. And Richard, thanks for all the behind-the-scenes work that goes into getting this all set up, not only the meeting. Let me just change my view a little bit. Not only the meeting, but also, scheduling the speaker and, finding speakers. It's a lot of work. And yeah, I've given a lot of talks over the years, although I was thinking when you said that number that, quantity doesn't mean that they were any good. I might not have learned anything over all those hundreds of talks. But again, I hope you enjoy the talk tonight. I think probably best is to wait on questions until after I'm done. And that way I can keep sprinting. We got a lot to cover. It may at times feel like you're drinking from a fire hose. I hope you'll forgive me. I keep trying to cut down my show, cut out slides, and there's just, as you know, who've given presentations, it's just hard to get rid of that key slide. Of course, they're all key before you're done thinking about it. Let me share my screen here, and there we go. So Richard, you can see that prism there? Great, thanks so much. So how have we managed to discover so much about the sky when really, let's get Microsoft set up here, where we've really just barely left home. We're still essentially earthbound, really. Images, of course, that we all capture are two-dimensional, and we can see a fleeting third dimension during eclipses. Oh, and by the way, Richard, people can also see my talking head, so when I gesture, they can see me okay. Mike Sinclair, can you see my face? Good, good. For better and worse, I think you need a thumb up and a thumb down. So if we wait for a while, we can see a fleeting fourth dimension, and that's time. You can see some stars, there's one in the upper right-hand corner, for example, that are going on and off. And if you spread the colors out, you get an as-if fifth dimension. It's gorgeous in itself. The colors are beautiful. It's fun to try and see where's blue end and the green begin. They're really gorgeous. And this is like a barcode for stars, not only our star, but all stars. And with those barcodes that we see, which we'll be talking about tonight, we can learn a lot about stars. I'm not going to read the bullets here because I have learned that over the years. I'm going to show you examples of these as we go through my presentation, though. So as I've been giving these talks, I realized there were certain key points that I wanted to make. And I figured, let's just lay them out up front so that you know what I'm talking about, why I'm talking about it. Now, you might not be an imager. Maybe you never imaged before. But if you did image, you probably remember that first image you captured. Probably like me, it was the moon. I know mine was blurry and overexposed. It was still the most gorgeous image. My wife got tired of me showing it to her and friends. And, the thing is, thrills being what they are, it did fade. But I found that when I got into spectroscopy years later, it recaptured that thrill, which is, of course, one of the things we're looking for in doing this as a hobby. Maybe you want to do some science. That was really one of the main reasons I got involved in this, is I just wanted to.
I couldn't hear what you said.
I guess Siri needs to be thrown off to the side there. And maybe you want to try a new activity, but if you're like me, you don't like taking risks and spending a lot of money, I'll show you some really inexpensive ways to get started. I think this number 7 is the biggest one for me. When you own the data, your whole relationship changes to it. It's no longer this passive understanding. It's like no longer, like when we read magazines, typically, we'll read a paragraph, or most of us will, and sort of understand what they're saying, and that's good enough, right? But when it's your own data, you're going to understand everything you can or that you care to. And so I found that I was learning a lot more, and I was remembering it, which is really important at these years that many of us are in. I know you've got your observatory there, and I'll show you some great examples for outreach in a little bit, but dark sky sites are getting harder to get to these days. And spectroscopy is really much more immune to urban light pollution. We're not interested in all that fancy color balance and the care that goes into creating an aesthetically pleasing image. Thank goodness you don't need to have a PhD in astrophysics to do this. In fact, I have a quote I'm going to use in an AAVSO presentation tomorrow. For the first time, I like to try new things out. And this is going to be, if you waited until you had a PhD before you enjoyed the stars, ... you wouldn't be an amateur astronomer, right? And, you know, I'm going to talk about a lot of things tonight that sound, you know, pretty scientific, and they are. But unlike that broad river that's really shallow. So you don't have to know a lot to do this, and you get to choose if you want to dig down deeper and learn more about what you're looking at. I'm all thumbs when it comes to imaging. I don't have the equipment or skill or really interest in taking those hour-long integrations or 20-hour-long integrations. And I'll show you things you can do with a video camera tonight. And I break everything pretty much. Edit undo is my favorite command in Windows, Control Z. And again, this isn't a kind of project where you have to assemble some complicated piece of equipment. This is what I mentioned earlier, and that is for doing outreach. I know that you all do some there. Richard was telling me before the meeting. And whether it's outreach or whether you want to mentor, being able to go into a science teacher and you know, somebody in high school and offer to be a mentor. You've got the telescope, the knowledge. You don't have to be very deep to really give a high school student just a fantastic experience and a science project that often wins. And finally, maybe you want to hang out with a cool crowd. That's not me. It's not autobiographic. But there are thousands and thousands of amateurs doing this today, so it's not like you're on the bleeding edge. A little bit of science and history to get started. You may recall that Newton discovered we could split light through a prism into its component colors. We can also split light by just bouncing it off a finely lined surface like that DVD, or through a finely lined surface like a piece of glass, and that's called a diffraction grating, and that's what we'll be seeing tonight. Bunsen invented the Bunsen burner, if I can find my mouse here. Well, there it is. He invented the Bunsen burner to burn samples, put them through a prism and look at the result. He was a real pyromaniac. He burnt everything, and he kept a catalog. And that catalog served future generations for a long time and really helped us get started in understanding the stars and understanding the science behind them. Kirchhoff was a friend and colleague of his. We're not going to talk a lot about him, except one real quick thing here. And that is, we're not going to do this whole slide. Notice this spectrum has a continuum, a Roy-G-Biv rainbow in the background, and it's got some lines, whereas this spectrum down here has a more or less black background and some lines. One cool thing is the lines really are in the same position, whether they're absorption or emission lines. Now, what you get, we won't get into tonight. It has to do with the temperature of any gases, the light's going through and so forth. But we'll see examples of these as we go along. So these lines, whether they're emission lines or absorption lines, are like fingerprints. So you'll notice that this line here in hydrogen just doesn't exist in helium. In fact, we name the hydrogen bomber lines hydrogen bomber. That's not a good sentence. We name these lines in hydrogen the hydrogen bomber lines. And that's because they're very common. It's nice to have a way to talk about them. We've even given each line a Greek letter, like we give the stars in intensity order Greek letters in the constellations. For example, this hydrogen beta is what sort of robin egg blue, and we've got the gamma and the red alpha over here. Here's a periodic table. We won't get into this in depth. We're going to go through each of these elements, and there's going to be a quiz on them in about an hour. No, this is a periodic table that I put together a few years ago. We sell them mostly to educators. You can see there's the hydrogen, there's the red hydrogen alpha, there's that robin egg blue hydrogen beta and the gamma. And you can see, for example, helium here, like the helium that you would put in a balloon at the florist, very different lines. They really are fingerprints. It's a remarkable fact that really has served humanity well. So we don't have to burn things anymore. This is a gas tube actually appearing in my software. And I can show you over here just so you see it's pretty straightforward. It's just like a fluorescent tube. This one, you can maybe see the HE label on it. I don't know if it's going to focus there. There it is. So we don't have to burn things anymore. And in fact, we actually have this camera that uses our software for physics and chemistry and astronomy teachers. A lot of schools, high school and colleges use it. So in 1835, let me turn off this gas tube here. In 1835, this guy, French philosopher Auguste Comte said, we'll never know what the stars are made of. They're too far away. But it was just a few decades later when all sorts of people were studying the stars with spectra. So far, everybody I've mentioned have been, old white men. Let's look at some of the non-old white men. Annie Jump Cannon and her team of women called computers, more than 100 years ago, were prohibited from accessing the telescopes at Harvard because of their gender. And so what they ended up doing was studying the gas plates, the photographic plates of spectra. They classified hundreds of thousands of stars, and through their hard work and ingenuity and intelligence, really, they're bright people. They came up with a star classification scheme that really, really has served us well. Priyamvada Nataraja studies hyperactive black holes. Nancy Grace Roman was the first astronomer at NASA. She got her PhD in astronomy in the late 1940s, and she was a big proponent of the Hubble Space Telescope that you can see there. Elisa Quintana, she studies exoplanets and has found some exoplanets around some older stars right in the Goldilocks region where there could be liquid water and perhaps life. And finally, Jedediah Eisler is at Dartmouth, and she studies gravitational lensing and black holes. So this was a slide I put together this past summer, and it was exciting for me to do because there are just so many other women. Exciting to find them, but disappointing that they hadn't had more visibility or opportunities. We've come some way. We've got a long way to go. So a little bit more science. How do we get these absorption and emission lines? Well, you'll recall the Bohr model of the atom has numbered orbitals. The electrons are in different orbits, and they drop down. And when they drop down between orbits, they emit light. And that light, again, differs depending on the drop. So for example, this one here is dropping from level 4 to level 2, and that gives us, well, that aquamarine, robin egg blue hydrogen beta. So that's how we get these lines, by electrons jumping around. Now, if an electron is jumping up, it absorbs energy, and then we get a gap. So we won't talk much more in detail about this, but it's just good to know in principle. And it is amazing to me, in principle, we're going to be studying the effects of something that's down at the atomic level and that we can see with our eyes with such simple equipment. Now, I used to move on after I made that statement. And then the other day I was thinking, that's not so remarkable because everything we see is that. Every single thing, that color you're seeing is because of the atomic principles involved in that material. So it's not unique that we're seeing down to the atomic level, but the kinds of inferences and conclusions that we can make is somewhat unique. Here's a Hubble spectrograph being serviced by the space shuttle. My teenage grandson says that this is not a scientific instrument. He says that it's a refrigerator and it's filled with beer because on the space shuttle, when it was flying, they were real party animals at night. And, you know, in 24 hours, they got a lot of nights on the space shuttle. He knows better. So here's a rather complicated device, but that's not what I wanted to talk to you about tonight, although it's enough to scare anybody looking at all those wires and so forth. There's a little, neon tube or something. Just, I love it. It's just jammed in there.
Hey, Tom.
Yes.
Dale Mayes is a KS member.
Oh, he is? Oh,
he is.
I was actually going to say a little bit more. It's really unfortunate you had to mention that to me. Oftentimes I will say, Dale gave me permission to use this, but sometimes I wonder if he doesn't regret it because, probably, really, talk about world records. This is a dubious one to have, but I've literally given this talk, say, 300 times. That means I've probably talked to close to 10,000 amateurs. There are 80,000 subscribers to Sky and Telescope, so that's an appreciable percentage. So he's now had this rat's nest shown all over the world. He's known for that. He'll be meeting people for the rest of his life and go, Dale Mayes, yeah, I saw, what a mess, But I need, as long as I'm here, I'll use one more line that in the past I've used on occasion here. It's really too bad he's not here, so I can't tease him. What I really like, you see that little pin right there? I picture Dale out there with alligator clips, and it's high voltage, right? It's some sort of gas tube, and clipping on. And of course, there's the danger of shock, but the real risk is if he draws a spark, he's going to ruin his night vision. So some of you should pass this on to him. So he's, you know, after a few of you have, when the next of you who start the story, he'll go, yeah, I've heard it all before. Do that for me if you would. Anyway, great guy. So I want to talk tonight about something much simpler, and that's the star analyzer grading. It's like $200. So it's certainly not expensive to get into this, nor is it complicated. And this has just a finely lined piece of glass in it called a diffraction grating. You can see our first example here, we've got it mounted on the nose piece of a DSLR. And there you can see the hydrogen alpha there, and the robin egg blue is a hydrogen beta and hydrogen gamma, just with a DSLR. Now notice this doesn't even have any tracking. It's not all that easy. You've got to get things oriented right in a small aperture. Although I heard a talk today by a 21-year-old young woman using a 8-inch Dob without tracking and video and getting drift spectra. So it's all possible. It's a little bit more work. It's much nicer in every case to have tracking if you've got it. There's lots of, and then there's these high resolution slit devices I wanted to mention. These you can see here, they're considerably more expensive. Now they have like a 20 micron slit. And so what that means is you've got to acquire your target and track it with that small little slice of the sky. These are a lot harder to use. You can build one for like $500 if you've got a 3D printer, but almost nobody starts with these just because there's just too much to master in one step. Let's see, there's a DSLR. That slide, I've been reorganizing my slides a little bit, and that sort of just dropped in there. It's like, well, what's that doing there? It sort of works. But you can see you can piggyback your DSLR on the telescope if that's the kind of approach you want to take. Okay, enough about all that. What can we actually do? You know, that's why we are here, to talk about what's doable. But actually, that's not why we're all here. I meant to mention when I was showing you that numbered list, even if you're not an imager, let's see how many people we have here right now. I'll see later, but we may have lost some who went, oh yeah, I'm an imager, this isn't for me. Even if you're not an imager, I think the next half hour or so, you'll see examples and understanding how spectroscopy can be done. Even if you're an armchair astronomer, maybe you don't even go out and observe. Understanding spectroscopy means that you'll have a basis to understand what's about 70% of the physics and research that gets done in astrophysics. It's really a remarkably powerful tool and gets used in just about all the research that gets done. So if we put a grating, as you see here on the screen, in front of a star and put a sensor, a CCD, behind it, you get that spectrum. Here's a really cool example. This is done with just an 8-inch Newtonian and a video camera. And these are separate spectra captured at different times. So, and they're in temperature order, starting with hot and going down to cool down here. You can see the labels there. These are in Obia fine G KM order. In fact, the other day, if I can find it here, I keep meaning to pull it out. I don't like that the traditional way that's expressed, Obia fine girl, kiss me. I don't think that's a good, somebody's not muted. I don't think that's a good acronym. So I was looking for better acronyms. And the acronym I found isn't all that good, although it applies to most of us here. Okay, boomer, a fully green kilowatt matters. That's the best they could do. Anyway, look how these stars differ in spectra by temperature. So, and if you, there's my mouse. If you look, for example, down here, look at those wide bands. Those, you know, those aren't even lines. That's like a forest. But they don't exist up on the hotter stars. Well, those are like a complex molecule that are in the shell of the star, and the star is relatively cool enough that they can survive. So when you see a wide band like that, you know it's a relatively cool object with some sort of relatively complex molecule, not just, you know, simple elements like hydrogen. One other example on this screen, and that is here. In the robin egg blue, this is the hydrogen beta line from the hydrogen bomber series we talked about earlier, right around 4,800 or so. Notice how this line is more prominent for this type A star than any of the other stars. Well, remember, these are being created as electrons jump between shells, down or up, whether they're emission or absorption lines. So what happens is these hot stars are so hot that when the electrons are traveling up, they go right past level 4 up to level 5. So they never get to drop between 4 and 2. And same thing down here. These stars are so cool that a lot of the electrons don't even get pumped up to level 4. So that's all the chemistry we're going to talk about tonight. It's nice to know a little bit, but this is about all you need to know. And even what I just described, all you need to know is electrons are causing these lines. And from that, again, all sorts of interesting results can come to us. Now, my wife always insists that I dress for success. And I thought from a style standpoint, color matching, this is probably the best slide to do it. Down here, you can see the hydrogen alpha line. And, the problem is, off the record here, and I know some of you at home are going to know exactly what I'm talking about from you or your spouse. If you look way down there, it's no longer red, and we're all about color here, right? It's gray. And that won't do, but my salon isn't answering the calls. I call them, they don't seem to be open when I drive by. And so, like I said, I know some of you at home know exactly what I'm talking about. My wife does say dress for success, but she's assured me this is not what she had in mind. Go figure, So you see that crosshairs there? Maybe you can see right where the cross is that there's a little bit of dimming. I never know whether that's really seeable or not. Maybe it's just averted imagination, So, but if I was to get time on the Hubble spectrograph and wrote a paper and said, yeah, we got in the Raman egg blue, we got a little bit of dimming. That's not publishable. We have to be quantitative. And the way we do that is we create an intensity graph. It's pretty straightforward. This axis here is brightness. So the star is very bright and narrow, right? So this is very high peak and very narrow. And whereas this thing, you can see up here, it's dim, brighter, 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 dimmer, 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 dimmer. So it's dim, brighter, 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 dimmer, dimmer, dimmer. But the cool thing is, look at that dip. Now we can do science. Now we can look at what color is that? Well, it's in the Raman egg blue. What color is it? How deep is it? What's the full width half maximum? Does it move over time? How's it compared to other stars? How's our instrument compared to other instruments? That's the science. So now how do we get that graph? So my story is I got one of these adapters, or little star analyzer grating, in 2009. I started doing astronomy in the early 1990s because I wanted to see Shoemaker-Levy 9. And I'll tell you a little bit more about that in a few minutes. And I went outside, right outside this window out here with my C8. I'm 3 miles from Pike Place Market in Seattle. One Saturday night in August, I actually found it the other day cleaning my office. I was just using a webcam. You can still see the duct tape adhesive on the webcam, and I'd taken the barrel of a eyepiece and sort of taped it all together. Came in at midnight, had some video of Vega. I had a sore neck and grass stains on my knees because, it's August and it's Vega, right? So next morning, Sunday morning, I'm all ready to create this graph, right? And I can't. I try some of the freeware that's out there and I can't get some of it installed. It's half in French. There's no manual. It's just not up to the usability standards that we become accustomed to. So what did I do? I gave up. I told my wife, I'm so frustrated. This is a hobby. I'm supposed to be having fun. So, I really wanted to do this. So a couple of weeks later, I said, look, Saturday, I'm going to sit down. I'm a programmer by trade and just do this graph. Just a simple program. Sunday morning, I was done. I had my graph, and this literally is it. This is that image, a frame from that video, and that's the graph, the first graph I got. And now 10 or 15,000 hours of programming later, I'm almost done. My wife keeps saying, would you finish the program so we can start having dinner at the same time at a decent hour? It's done, really. And it's been a lot of fun for me. It was just something I did for myself, and then other people wanted to do it. I think one of the obstacles for us to do anything new like this is, oh no, another piece of software to learn, right? So I want to spend just a moment showing you the software. Again, I know it's after dinner there. Here in Seattle, it's only 4:30. But there, I know if I do a longer software demo than a couple of minutes, you know, I'll start hearing, if your mics weren't muted, I'd start hearing thunks as your head hit the mics, you know, and we'd all get views of the top of your head for those of you who have your video going. But with less than a dozen clicks is really all I want to show you what this is about. So this is an image I captured in my video. It's a single frame. Could be a FITS image, could be a mono camera, could be a color camera. It's really easy to, most any camera capture spectra. Use your standard camera capture software that you've always used. Or if it's video, you may be able to capture it in RSpec. I like color when I'm doing outreach, although mono is a little more sensitive and pure scientifically. See that gap there, and see there's some gaps there. So all you do, and you can do this under the stars, which I now do, and many people do. You bracket in the region you want to observe, and now you've got your spectrum. Look at that tall peak as the star, and that data there is that. You see that deep dip right there? That's that dip. That's a spectrum. Big deal, right? So what? There's dips. What are they? How do we interpret them? Remember I mentioned, this hat gets a little hot after a bit. Remember I mentioned that Bunsen created a catalog? Well, the great grand catalog from him is built into the software. So we can come down here and say, when I check this box over on the graph on the right, show me where the dips would be if this star, this is Vega, if this star had some hydrogen that was causing absorption features. And look at that. We've got a dip there, 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 there. Pretty cool, huh? So now with a backyard telescope, first time out, I'm a terrible imager, trust me, and a webcam, this is an old Logitech webcam, we're actually detecting the influence of the hydrogen shell, the outside shell of that star on the light as it leaves that star. It's pretty amazing. This is really pretty. And in fact, this is a stopped video frame. It's I'm going to start it. It'll play at 2 frames per second from that first night. And you'll see over here, the image is moving around. And of course, the graph would move around. That's just our scene changing. But what's really interesting is some of those features come into view and then disappear. If we look at this hydrogen alpha feature here, you can see it's sort of always there, but it's always different, right? At 2 frames a second. Most of us know about stacking and how if you add images together, you eliminate noise. Check this out. I'll turn stacking on. Watch how quickly that image becomes stable, sort of rounded, symmetrical, sort of Gaussian. So, but when I'm doing outreach, and this is one of the screens I wanted to show you, I usually leave it at this without the stacking. This really attracts people. And this gives you, again, with just a little bit of learning on your part, gives you a platform to talk a little bit more about science. And I'll show you after my talk in the Q&A, if we have time, a little bit. There's a solar spectrometer you could use for your solar outreach. That's all I wanted to show you. Let's see if I can get back to the show. There we go. Here's an outreach, some sort of public outreach. They're doing, starting with a gas tube, which is what I've got here captured on the picture on this image. You might not do this at a dark sky site with all that light color there. This is in Marseille, France. You can see the spelling of various things there. Here's a DSLR image to give you an idea what the whole sky looks like. And you can see there's a handful of stars here. Here's their spectra. There's some gaps, right? Here's a star here, and there's some lumps, right? Those are emission lines that have saturated the pixels. Let's look at another DSLR image of a Wolf-Rayet star. So when Janet Simpson sent me this spectrum, and it's a little pixelated here because I blew it up. When she sent me this spectrum, I have a confession to make to all of you, and that is I couldn't remember what a Wolf-Rayet star was. You know, I'd read about them over the years, but you know, things do go in one ear and out the other. I might have read about them half a dozen times. It's one of those things you sort of, you know, move through in an article because, you know, it's almost dinner time and you want to finish the article before it's time to eat. So there's the spectrum. And in this spectrum, we see carbon, carbon, carbon. Well, why would we see carbon? Well, remember that stars burn through the elements step by step, hydrogen to helium, and carbon is along that pathway. And we're seeing, these are massive stars. I mean, just incredible, like 25 times more massive than the sun, unbelievably bright with extremely high stellar winds. And we can actually, the stellar winds widen these peaks so that we're able to easily see them. Now, this is the kind of thing you go to Wikipedia on, and that's all I know about Wolf-Rayet stars. If I've read more about them over the years. There's 2 different branches. There's all sorts of things. If it tickles your fancy, you read about it. Otherwise, you move on and look at something else that is more interesting to you. Here's another emission object, our beloved M57. And you can see here that there are really just 2 emission features, hydrogen alpha, and this Roman numeral 3 means ionized, so there's ionized oxygen. It just means an electron's been pulled out. So, or more. So this is an extended object, right? It's not a point-like object. So with the star analyzer grading, there's no other extended object that is as interesting as this. Most are just going to be a smudge. So to look at extended objects, we need those slit devices. And here's our beloved Orion Nebula with a slit device. And there you can see our hydrogen alpha, and there's the Roman numeral 3, the ionized oxygen. Nice tight features, and we can see other things, but that's because we have that expensive and tough to use slit. So my experience in the early 90s, like I said, I wanted to observe Shoemaker-Levy 9. 9? Yeah. Or was it 1? That's what age does to you. So I went out to the Denver Astronomical Society. I was living there at the time. It was in the city, first quarter star party. I walked out on the field, the observing field, on a little hillside overlooking it. And, it's fun to remember before you knew something. Well, when I looked out on the observing field, what I saw, and this is not that field, this is from a club I spoke to a couple nights ago, I saw these things that to my uneducated eye looked like the cannons that they shoot people out of in circuses. Honestly, I'm going, what is this? Of course, they were doves. And so I queued up. It was one of the doves was being run by somebody, much like us, talking about what we were seeing. And I'm all excited. I'd seen pictures in the magazines. And I got up there and I was really disappointed. It was a smudge, right? It was a mono smudge. It was nothing. I bet many of you had a similar experience. So, but still, I bet many of you like me still come back and look at M42. Why would we come back if it's still just a boring smudge? Well, we've got better telescopes. We've got darker sky sights. And also, we know now how to use averted vision, right? With averted vision, we can see a lot more detail. But in all seriousness, the reason we come back is because we understand more about what we're seeing. We know it's a birthplace of stars, a stellar nursery, and these gas clouds, and they're being heated, all that. And the reason I mention that is because I found that's what happened with me and spectroscopy, is the more I've understood a little bit more about what I was observing or imaging by using spectra, the more my experience of observing was improved. Here's the spectrum of Uranus and Neptune, done again by Torsten Hansen with a video camera. There's some deep, wide bands right there. And when we see bands, what do we know? We know it's not just a simple element like hydrogen or helium. It's a more complex molecule. In this case, it's the methane. So when we discover ET, it's likely we will discover, or at least infer or claim, I'll let you choose the verb, it will be at a distance. We will observe something like we thought we did in Venus's atmosphere recently, that we believe could only be there because of life that created that. And for example, it could be oxygen. Oxygen doesn't last that long. So if you find oxygen on a planet, you need to figure out, well, who's pumping that planet full of oxygen, that atmosphere? It's either life as we know it, or it's some other chemical process. So in 1881, Henry Draper observed a comet spectroscopically. Heck, if Hank can do it, so can we. There's the spectrum. I love that string of jewels. Aren't those pretty? And there, down there on the right, you can see the peaks, the intensity peaks from the profile graph called the Swan bands, and there was mostly carbon. Now, this was captured by a guy named Vikram Agnihotri. He's a nuclear power plant engineer in India, in Northwest India, in Rajasthan. In 2013, he was a newcomer. Now he's an expert, and I learned from him. And what teacher doesn't like to learn from their student? It's wonderful to see the work that he's doing now. Here's a more recent, timely, contemporary example. This is Neowise, and the tail, you can see the sodium. And this is just done with a DSLR with the grading right on the nose piece, like that first example we saw. It's called an objective grading. So I love this. Anybody who uses just a C-clamp, as part of their setup. That's my kind of do-it-yourselfer. Of course, if it was me, I would crank that clamp down too tight. And what would happen is I'd buckle the housing and the camera would be ruined. Fortunately, Robin Leadbeater didn't do that. He's the developer and the designer of the Star Analyzer, one of which he put on the nosepiece of this video camera. Down here, he captured the spectrum of a comet. That's a single frame. It moved that distance during that frame. There's the spectrum, and right there, that gap is that dip right there. So this is a rather specialized area for amateur spectroscopy, but it's doable. And, you know, whatever floats your boat. Some people do this and love it. I won't get into a lot of sun talk, since we heard a fair amount a few years ago and will be in the coming years, except that we discovered helium on the sun from its spectrum first, before we found it here on the Earth. It's a remarkable piece of science. If you're into novae, some have iron. You can see them. This is actually just with an unmodified DSLR. Some don't have iron. A quick review, Doppler shift is the pitch change that occurs when things are moving. For example, you know, somebody was yesterday used the example of a siren. I don't like the siren example because sirens are changing pitch intrinsically, just, you know, because that's what many of them are meant to do. I think of the train whistle coming through a station, right? High, low, high coming towards you, low going away, because the light waves are as if stretched or compressed by your movement. You can actually hear that tomorrow while you're out in your car doing your honeydew list. Roll down the window if you're on the highway or there's trees going or parked cars, and you hear this, right? That's going from high to low as the things go past you. So it's everywhere. Now, if we were expecting to find three features, this triplet, say, right there, and instead, when we observed it, we found them over to the right, we'd know that that object was moving away from us because the light rays had been, the waves had been stretched. If they were over to the left, we'd know that the object was moving towards us or us towards them. It's all the same. And it was blue shifted. Let's look at a really cool example of type 1a supernova. There's lots of different types. I won't get into a lot of detail here, except this big star ends up with some of its gas on this white dwarf. And when you pour gas on a hot surface, what happens? You get an explosion. So here in M101 was a supernova. There's what another, it's not this one, but it's the type 1a supernova. See, you can even get a sense for there's, you know, expanding explosion, some sort of shell there. Well, there's the spectrum captured by David Strange with a 9-inch telescope in less than 15 minutes of stacked images. And there's the spectrum. And look at that dip. We can barely see it visually here, but it's very clear here. Now, you know, we say that we stand on the shoulders of giants, and in this case, we really do. The giants have figured out that there's different types of supernova. This is a binary system with two stars. There's other supernovas where the star, just one star runs out of fuel and collapses, core collapse. And what they figured out is each of these supernova types have a different spectrum. So here, a type 1a supernova has this really deep dip right around 6,000 that these core collapse supernovae down here don't have. And that's silicon. So what David Strange was able to do is determine that this was a type 1a supernova. And that's one activity the professionals would like amateurs to help on. And it's simple to do. This is the way professionals identify supernovae. The only downside is supernovae are fairly dim, so it requires a fairly big telescope. But look what David Strange did, and with me, we both did this together. There, we measured the wavelength of that dip. And then it's real, you know, this is a new title for this slide, first time tonight. And I thought, you know, is that like a contradiction of terms, or is that like totally nerding out as a math person? But look, we measured that wavelength down at 6150. If Bunsen had burnt silicon like beach sand, he would have found that that dip was at 6355 angstroms. That's what this x-axis value is, or label, unit. So the difference between them is from Doppler shift. So let's look up the Doppler shift in Wikipedia. I couldn't remember it, and do a little bit of math. And now we've calculated the blue shift from the shell of that supernova coming towards you at 22 million miles per hour. Wow. Now, you know, Adam Rees and his team won the Nobel Prize a few years ago, almost 10, for work he and his team did before the turn of the century. They were using supernovas to measure the cosmological expansion acceleration. And I don't think they used a piece of equipment like as simple as this or inexpensive as this, but it's neat that you can do the same thing really with your own equipment. What about the spectrum of a black hole? So You know, a black hole, of course, doesn't emit light, but the accretion disk, as the matter is spiraling down into the black hole, that matter gets very hot and emits light. So David Hayworth observed this quasar. I've never observed it myself. There's the spectrum. You can see two little dots at the top of those arrows on the right. There they are, there, just zoomed in, and there's the spectrum. Now, in the mid-60s, this guy was in his mid-20s, Martin Schmidt, and he looked at this and he thought, what are those peaks? And he got really frustrated. He was having trouble. He said, I'm going to go back to square one. He said, first, like a lot of science, let's eliminate what they aren't and see what they could be. So he said, let's eliminate those being hydrogen, which of course is so common. So he brought up a reference. This is the reference from my software. This is actually the same screen I showed you a little earlier, mainly to show you these blue reference lines. That's where the Balmer series would be, right? There's the Robin egg blue hydrogen beta. But he went, well, they sure don't line up with those peaks. So we know those peaks aren't hydrogen, except they were. Really massively redshifted, which meant this object was an incredible distance away, and yet bright enough that we could still see it, which means intrinsically it's enormously bright. So what is astonishing to me is that this light that has traveled for such a long time over such a great distance still has information in it that we can tweeze out, and learn something about that original object so many billions of years ago and away, light years. So light doesn't seem to age. Other things in the universe don't age as well, right? Here's Martin Schmidt a few years ago. I've been justly accused of throwing stones in a glass house. And really, I mean, look, he's got a full head of hair and I don't. But anyway, remarkable discovery. And there's an interview with him on the web, linked to from my site. I'm happy to give you the link via our contact form if you ever want it, where he describes the whole process of discovery and his fear that he was wrong and all that went into it. And when he got home that night, he said to his wife, he said, something terrible happened in the lab today. And what he meant is he anticipated what the publicity and the celebritydom was going to do to him, who just wanted to do science. So 2 more slides and we're done. Suppose we want to zoom in and look at the details of just this little hydrogen alpha feature. That's what the details look like. This is that. But we can't do that with just a grating. There's just not the resolution. I mean, you might think, oh, just take your mouse wheel and just zoom in on this feature. But that's like adding anti-magnification when you're looking at the moon. Eventually you don't see anymore. It just gets bigger and blurrier, right? So to do this, you need one of those expensive devices. But when you do that and you can see this detail, one way scientists do things, as we saw in the previous example, is they compare an unknown to a known. Let's also superimpose on this the moon. So there's the moon spectrum. Now the moon's not really moving towards or away from us appreciably. Look at the difference in that peak or dip. That's Doppler shift. And so by measuring the difference of those and doing a tiny bit of math, we can figure out the radial velocity of Vega. And that's how professionals do it. Last example here, I've got somewhere, here it is. I've got a little visual aid. This is a planet. It's spinning very fast. And this edge is coming towards you. And this edge, it's not a planet, it's a star, excuse me. And this edge is moving away from you. So the light coming to you from here, it's coming towards you. So it's blue shifted. This light is, you didn't see me squint as I tried to remember which was which, but maybe you heard it in my voice. And this light is red shifted. And in fact, I have a slide here that I'm going to take just a moment to bring up. As I mentioned, I was working on some changes to my presentation. I didn't get this in, I just remembered it, but it's worth showing you if I can find it. So give me just one moment. I think it's this next image. Nah, it doesn't look like I can bring it up. Let's see, one more try. Nope, I can't. But this star has red and blue shift going on because of those edges coming towards you and away from you. And if it's spinning fast enough, we can detect that. What's it going to look like? Well, some of the light that normally would be at this peak is going to be spread out towards the blue, and some of this light is going to be spread out towards the red, or vice versa. So let's look at what that looks like. There. Notice how Altair has this rotational broadening. So the dip, because of Doppler shift, is really flattened out. And this is the way, for example, we study BE stars like Betelgeuse and other stars. With these Doppler shifts, we can learn a lot about them. Okay, let's just finish up real quick here. How do you get started? Well, you need a grating. I already mentioned that. Any sort of camera, mono, color, video, still, DSLR, cooled, uncooled. You need some software. This is a software I mentioned I had tried first. It's gotten a lot better. I'm good friends and was speaking just the other day to the people who wrote this. Very powerful software, still has some limitations in terms of usability and learning curve and so forth. And you may need a thread adapter or spacers because this distance here between the grating and your sensor, it's not like it has to be exact, but you don't want it too far away or too close. It's not, like I said, it's not as critical as, say, focus. So there's a calculator on our site where you plug in all the data for your telescope and setup, and then you look for some green flags over here. And either you use a calculator or you email me this information. And I do a lot of this for newcomers. And I'll just plug your information in, make a quick screen video, explain to you which mounting you need for the grating and whether you need a spacer or two that we sell for like $10. So on the links page on our site is a discussion of some of the books that are available. A lot of us learned a lot of what we know before the web was there or here, and things get a lot easier with the web. This particular book I wanted to show you, it's this one here. I think I have an example of, here's a sample page. Figuring out what dip is what is way over our pay grade in knowledge. But a book like this that points out, if you're looking at a ciphered galaxy, then it's going to have these peaks and it actually tells you what they are. But, for a knuckle dragging programmer like me, I don't know the significance of any of this stuff. Who cares if there's ionized nitrogen there? But the cool thing is this book also has a lot of text that is aimed at us, as us non-professionals and as amateurs, and explains what we're seeing. So there's a lot of learning to be done there. We've got an online forum that is just fantastic. Lots of contributors who know far more than I do. The power of community and the hive mind really works. You can download the software for free for 30 days. And I taught a few years ago an hour-long workshop to the AAVSO, and they recorded it, and it's on the web, linked to from our download site, along with the sample data that people were using in that workshop to follow along. You could do the same thing tomorrow. Download the software and install it, download the sample data, and watch the YouTube video. Even if you never put a spectrometer or any sort of grating on your telescope, you'd have spectroscopy in your bones after an hour or two. There's professional pro-am collaboration opportunities all over the world. Not as many as we'd like, but more coming. So in the last 200 or 300 years, we've come a long way. And of course, in the last 55 minutes, we've come a long ways, maybe 50. So I'd like to thank you all for inviting me tonight, for at least smiling at some of my jokes. I want to thank you all, especially those of you who are doing outreach, especially when things get back to normal. It's the way we pay it forward and pay it backward. And I know it probably fills your heart like mine to do that kind of thing, but you can make a difference, and you are making a difference by doing that kind of thing. So thank you for that. I'll be here until you throw me off the stage. There's my email address and website, and I love answering questions. You're always welcome to answer them now, or ask them now, but you can also ask them a day or a month or 2 years from now. I'd be happy to answer and help out. What brings me great pleasure is when somebody sends me a spectrum and goes, oh my God, I can't believe I got it. And that can happen the first or second night out. This is not the kind of thing that takes a long time. Thank you again, everybody. So if there are questions, just unmute yourself and go for it. You're muted there, Richard.
Yeah.
There you
okay. Go. There we go. So anybody have any questions?
Well, good. I'm off the hook. I'm going to get dinner on time tonight.
Oh, hang on. I'll have to cancel the spotlight video here.
I'm going to just jump in for a second.
Great, Dee Dee.
Tom, I saw you at the Lake County Astronomical Society meeting in Illinois last month. So thank you. And I have another Zoom meeting I have supposed to be at 7 o'clock, but thank you. And thank you all for letting me come and sit in this evening.
Glad you
Thanks,
came.
Judy.
Okay, have a good night.
Good night. You know, whenever somebody says they saw me before, you saw me go, oh. You know, if you ever see a comedian doing their stand-up routine and you hear how spontaneous they are, it's just off the cuff and they go, oh yeah, I was thinking. You don't want to see that comedian the next night or the next week a second time because you see just how unspontaneous it is. This talk was not memorized, but a lot of what I said she's heard before. The first or second repeat, it's okay. But anyway, what other questions do people have? Are there any?
You did well. Good night.
Thanks.
I have a question. How deep can you go with an 8-inch telescope?
Really, really good question. I didn't see who asked that. Who asked that?
Pete.
Pete. There's too many of you here in this meeting. I can't see all the screen. So
I wonder if she's
the rule of thumb is that you lose when you spread the light out. Of course, it's no longer concentrated on a spot on your sensor, so it's dimmer. So you lose 5 or 6 magnitudes. So if you can normally image, say, down to mag 15, you'll be able to image down to a mag 9 or 10.
Okay.
So that's the rule of thumb. It turns out there's tons of objects to observe at that brightness or magnitude. But that's a good question. I meant to mention that and forgot to.
Okay, great. Thanks. That's a reason to buy a bigger telescope.
There's always room for more. But as it turns out, actually, the sweet spot for spectroscopy, even with a slit, tends to be 8 or 9 inch telescope. And there's just so much to observe at that aperture that larger telescopes, you begin to get into a little bit of trouble, especially with a slitless grading, because the star size is bigger on the sensor, so you lose a little resolution.
Does the F ratio matter as far as?
Yeah, you don't want it too fast. Anything faster than say F4, F4.5, you get some sort of chromatic distortion because of the steep cone of light. In fact, you need a telescope that doesn't have a lot of chromatic aberration, which means a reflector or an APO of some sort.
Okay.
Good questions also.
Great.
Other questions? Well, good. Listen, thank you all again. If you know of other clubs who you think might enjoy hearing this, I'd love to speak to them. You might mention my name. And thanks again for everything. Stay safe. And I know I was gonna mention one other thing just off the cuff since I've got another minute here, and that is, I've been thinking about meetings and this collection of people. And again, for those of you who showed up late, you didn't maybe hear me mention it. If you're seeing me, or if you are seeing the speaker, whoever it is a big box in the middle with just a little strip across the top, like that. Rather than that, you can click the button that looks like this in the upper right-hand corner labeled View and select Gallery View. It's a toggle. You can go back and forth with that button. This is a nicer view in my mind because you see a lot of people all at once. And the reason I wanted to mention that, since we're not all meeting in person, it is a community, and part of, our lives are the people that we know and we share this with. Hi, Aaron's son, how are you? You missed my my wig here. It's hard to get all these colors in different orders, but and my wife's not happy about me doing this, you can imagine. But this is a community. And so sharing all the videos simultaneously, you get to see more people. It's like, the star parties that you've gone to. I just wanted to paint this real brief picture, sketch. And that is when you're standing out at a star party, it's midnight. A lot of people even aren't at that star party to observe or image. I mean, yeah, we do some of that, but the majority of us by midnight or 1 o'clock, we're just standing around, maybe sitting around with our friends. There's a telescope. Maybe occasionally somebody will say, hey, have you seen Stefan's quintet recently? And you go, oh, yeah, I'll take a look or whatever. But the thing we're there for is the camaraderie. We're underneath that cathedral of stars. We don't get that now. So I'm glad that you have such an active club with this number of attendees. It's a great turnout. It's one of the higher turnouts that clubs produce. And I'd also encourage you to show up a little early some nights and just hang out with your community here and chat, ask questions.
Here he is,
make it real.
Jack's brother-in-law.
Anyway, any other questions? Good. I've given you 3 chances. That's plenty. Have a great night, and thank you all again. I appreciate it.
Thanks for your time.
Thank you, Tom.
My pleasure. Good night. Bye,
Thank you.
Jack, Charles.
Thank you.
I did just want to add that Tom Field is my favorite kind of speaker. It's not the person or the topic; it's the fact that he volunteered to give it, and I didn't have to go looking for him. So that's
There
my
you go.
favorite type.
Tom,
Yes.
Tom, could you give your email address again?
Sure. Tom at fieldtestedsystems.com. If
Thank
you just
you.
Google Tom Field and spectroscopy, there's a contact form on the site if that doesn't
Great.
work.
Thank you very much. Appreciate it.
Yeah,
Enjoyed your talk. Yeah.
Thank you so much.
All right, thank you, Tom. All right, so hope you enjoy some snacks because we'll move on here since we still can't do a snack break. We're going to start, before we jump into the usual stuff, we're going to start with a special announcement. So I want to introduce Terry Mann from the Astronomical League.
Oh, yeah, that's Terry.
Thank you. As he said, I am Terry Mann. I'm the chair of this region for the Astronomical League. And thank you for giving me time to speak with you. I would like to thank your club for being part of the league. You have helped us learn, and you helped so many other people learn, and I'm very happy you're in the Great Lakes region. And I hope when things get back to normal, maybe I can make another trip up and attend one of your meetings and meet some of you in person. In the meantime, if you have any questions about the league or any problems, just get my email address from Richard Bell. I don't think it's in the current reflector yet. I just became secretary of the league. I was appointed September 1st. So Richard Bell has my contact information. And if you have any problems, let me know. But tonight, I'm here to present an award. As chair of the Great Lakes region, it is my pleasure to announce that Richard Bell is the winner of the 2020 Great Lakes Webmaster Award. The committee-
Yay!
Yay!
Congrats.
Congratulations.
The committee reviewed a lot of websites. This is a new award for the Great Lakes region. And so the committee reviewed a lot of newsletters, a lot of websites, looking over everything. And very honestly, yours stood out tremendously. Now, I want to read some of the comments that the people from the committee had made. Your website is visually stunning, very simple to navigate, rich in menu selections. And I have to agree with that. It's amazing. The history that is on there is incredible. Membership. Access to the remote telescope. And I didn't know about all of this. It was interesting listening to you talk. The programs, and I have to say, your gallery is fantastic. Those are some amazing pictures from the astrophotography your members do to the events. Everything on there is just incredible. I really enjoyed that one. And somebody said you even have links to astronomy companies. The one thing I noticed over the last probably month and a half, I've been visiting your website quite a bit. It's always current. And your focus is on public education and helping your members, helping new members. The education that you do to the public is amazing. Once we kind of put all this together, we dug a little deeper to learn more about Richard. Richard has ran the website for 23 years and been through 7 redesigns. He is also the editor of your newsletter, Prime Focus, for 19 years, and that is a fantastic newsletter. He has produced 225 issues of Prime Focus. We also learned that he is the longest serving president at KAS and involved in fundraising, and we all know how important that is. Involved on your online viewing session featuring the remote telescope, which is in Arizona, and conducting a 5-part introduction to amateur astronomy lecture series. Now, I'll be honest, we couldn't have had a better winner. You definitely are perfect for this. So with this award recognizes Richard for not only what he means to your club and your community and to public outreach, but also to the Astronomical League and to the Great Lakes region. Congratulations, Richard.
Thank you.
May I jump in?
You go right ahead and jump, Chuck.
Okay, thank you. As many of you know, Terry's the past president of the league, and I had that opportunity once myself. And so we've been around to a lot of clubs. I've visited personally more than 50 clubs. And one thing that you find out about astronomy societies is that there are a variety of reasons why people join them. Some join for the social aspect of it. Some do it because they like to observe. Others like the technical aspects, computer, website. Some like to write newsletters. Some enjoy imaging. Some get involved because they like organizational work, the administration of the clubs. And some do it because they like to educate others. And in every club, you'll find someone like Richard who does all of that. And so it's really fantastic to have somebody like him in your midst. And I know you appreciate that, but also we value you and your club, Richard, very much in the league. And so congratulations to you.
Thank you.
Do you have the plaque?
Yes, I do. You ready?
Yeah.
Here. All right. So I don't know if you can see it.
Whoa.
There you go, Richard.
Can you read it? Okay, here we go. So that's it. It's actually very nice.
It acts like a mirror.
It does.
It's hard to photograph. I found that out when I sent you the picture.
Yeah, I got the light right above me here, so that doesn't help.
Yeah, we definitely want some pictures of you with the plaque.
Yep, I'll work on it.
Okay, thank you very much.
All right, thank you.
It's well deserved.
Thank you, Terry and Chuck. He very well deserves that.
Definitely.
Sure.
All righty, so let's go ahead and move on here. So it is the November meeting, which means we have to do nominations for 2021 officers and at-large members. So let me bring up the screen here. I can't look at everyone at once and do the screen, so I'm figure out how I'm going to do this. Where is it? Here it is. So here's what we have. Of course, I announced back in March I did not really plan to run again. I figured 15 terms was plenty, but I guess we'll see what happens. So of course, everyone with the star next to their name is a current officer. Usually people just jump over to the next year. But of course, if anyone wants to run against them and shake things up a little bit, that's totally fine. So we can go ahead and open nominations. So does anyone have any nominations? We'll just say for any position. It's going really well so far.
Just like when we were in person.
Yep.
I don't know if Rich or Roger wants to continue to be the secretary. I know he's mentioned being willing to turn that over. It's a responsibility I'd be happy to take up if somebody wanted to nominate me, or if he wanted to continue doing it. He's more than welcome to keep it, but I'm happy to put myself.
I would back up that idea enthusiastically. I've got it for enough years.
Who's talking?
I believe that was Aaron, right?
Yes.
Okay, let me.
I nominate Aaron. This is Don Stillwell. Okay.
I'll second that.
So Roger, should I just remove your name altogether?
Yeah.
Okay. That sounds fine to me. All right. So I guess we'll have to take Aaron's name off this list here. Unless you want to try to run for two and see which one works out for you.
Well, if I don't get secretary and you kick me off the board, I guess that's what happens.
Okay. Anything else? Any other nominations?
Nope.
Okay, so we'll of course we'll save this. Nominations will be open until the next meeting, and we'll go from there. All right, so that was fun and painless. Well, not so much painless. So let me jump into the president's report. As usual, I have several things to mention. You guys know me; I'm always brief. So let me start with the bad news. If you paid attention to the local news, Kalamazoo Public Schools is going to be meeting remotely until at least March. So that means we will not be able to return to our regular meeting site, the Kalamazoo Area Math and Science Center, KAMSI, until at least April. So it'll be over a year before we possibly can meet at KAMSI again, but I'm guessing it might be longer. But as you can see here a bit tonight, we had someone from the Lake County Astronomical Society in Illinois. Over the past month, I've been trying to do my best to turn a disadvantage, this nightmare of a pandemic, into an advantage. So I recently, I mentioned, I think last month, that I contacted roughly 70 astronomy clubs in the kind of Great Lakes region, sort of a little beyond, but basically all the states immediately around Michigan. So I decided to expand upon that, and I ended up contacting 350 clubs roughly in the US and Canada. And believe me, it was really, really fun going to the various websites. Most of them I was on very briefly, just to grab an email address. Some email addresses I just got from like the Astronomical League website or Sky and Telescope's website. So I can't say I visited every single one, but quite a few of them. And there are some that I really, really like, but being the humble guy that I am, mine was definitely the best. So I can't help it. we definitely, I freely say this, we definitely have the best gallery out of any website around there. I mean, ours is just massive compared to anybody else's. So for me, that's the pride and joy of the website is the gallery. So if you haven't looked at it, take your time. So, but anyway, hopefully over the next few months, starting next month, as I'll mention later, and definitely January, February, and March, I'm going to look for speakers that we could otherwise never have. For example, Tom Field, he gave his presentation from Seattle. So I'm going to look for other people that would be very expensive for us to bring in to do an in-person visit and have them present. So again, I'm trying to turn a disadvantage into an advantage, find why invite people from MSU, U of M that we would have in person all the time when we could try to find someone far away and try to shake things up a little bit, try to have some different people. So we are going to be on Zoom here for a while. So I know I don't see Ellen Comiskey on here. I know that would not make her very happy from that rant she had a couple months ago. So yeah, we're going to be on Zoom here for a while. The next thing is I did get an email recently. I'm on the wrong page here, but I'll just switch to the other tab real quick. So I got this email from Hazel Anderson at MSU. She's looking for basically science festival proposals. You can do talks, demonstrations, give virtual self-guided tours. I might submit something about the remote telescope, but I'm sure they're looking for something earlier in the day, but I could give it a shot. And other types of presentations. So if you're looking to maybe possibly give some sort of talk or performance or demo or whatever, I can forward this email to you from this person at MSU, and you can check that out. So I just wanted to mention that. I did want to talk about the remote telescope real quick. It's fully operational, but the only thing I still have to set up is the flat field routine. But I'm happy to report after the training, the last training session that we did last month, it is getting extensive use. In fact, last week, it was used every single night, and it's basically been used, I think, every night thus far, except for tonight. I'm supposed to be using the telescope tonight, but the weather looks like it's going to be a little cloudy out there, so I don't know if I'm going to be able to use it tonight. So I just wanted to mention that if you did recently pay to use the remote telescope or paid in the past, and you want to get some time on it, you might want to get to the calendar and reserve something now, because there's been 3 people that recently took the training session that have been using it a lot. And so they've been kind of hogging up all the time, but no more than they're allowed. So if you want to use the telescope, have at it. Go to the schedule the reservation page, find yourself a good spot, and reserve some time before they hog it all up. So it's been great. I do gotta have a talk with those guys again though, because they don't seem to watch the telescope from time to time, and so we have some amazing images of the bottom of clouds. Really exciting stuff. So they need to keep an eye on that. Let me talk about some upcoming events. I'm going to share my screen here again just to make this a little more fun. So I mentioned last month that I'm going to try to do a 12-week college level course. I'm doing this on my own. This is technically not through the Kalamazoo Astronomical Society, but you could say the KAS is sort of an informal sponsor. And I'm happy to report it looks like the class is going to go forward. I currently have 19 people signed up. I'm hoping to get at least 24, but 19 is pretty good. I've had smaller classes than that. The smallest class I ever had, I think, was 8 at Glen Oaks Community College, which is really fun. It's really fun teaching a small class as opposed to larger ones. You really get to know the people. So, for example, if you want to dive in a little deeper into spectroscopy, why there's spectra in the first place, all the physics and astronomy of that, we dive into that fairly deeply in chapter 6. It is a pretty in-depth course. It'll give you a well-rounded education in the basics of astronomy. And if you have not done so, you can check out the syllabus. You can find that on a slide that looks very much like this one on the KAS website. So you can check out the syllabus, contact me, see the schedule, and just get my general philosophy of the course. Because as I mentioned, there are exams, but there are no grades. I don't grade anything. You just take the exam. I send you the answers after a certain amount of time. You check yourself, see how you did. So basically it's a course of self-development, no grades, no credits, just learning. It is a pure educational course. The questions I get the most is, how do I pay? So far, I'm not going to talk about that yet. I'm going to make a final decision about the course going forward in mid-December. But again, I think it's pretty likely that the course is going to go forward. So much so I've been updating the lectures. And the other question I get is, when is the deadline? There really isn't one. Frankly, you can pay on January 12th, the first day of the course, and you can jump in right from there. And also, each lecture will be recorded, so you can watch it on YouTube later. I'll have them at secret links on YouTube where only the students can check them out. So give it some thought and contact me if you're interested. And of course, as Terry mentioned, I'm doing this 5-part lecture series again. This is, I think, roughly the 7th or 8th version of the Introduction to Amateur Astronomy lecture series. So by this point, it's pretty much perfected. Although, of course, this time it'll be a bit different because it'll be online. It won't be at like the Portage District Library, where we had some huge crowds for this. For some of the first lectures, we had roughly 90 people show up in that small room at the PDO. So you can register for this through the website. Of course, this is absolutely free. There is a teeny amount of overlap early on in the class from the lecture series. So if a handful of people are doing the class and the lecture series at the same time, so they're going to hear some similar material, at least for the first week or so. But after we get past the first week of the class, it's like really all new stuff. So if you want to register for the lecture series, just go to the website and fill out the form. Some people have mentioned they've had a little trouble with the form. So if you do get an error message, just email me and you can do that. So I'll come back to the other screen here later. There's one more screen I wanted to share, but we're not quite there yet. And I just want to mention, I haven't worked on this too much. I haven't contacted anybody else again because I've been so busy working on other stuff, but we're still going to try for a KAS astrophotography special interest group, a AP SIG, where we basically have meetings just for imagers. but again, I've been kind of preoccupied. But if anyone else wants to take the ball with that and organize that, you're totally welcome to. You know, for a lot of the stuff, it's usually, you know, Richard, but he can't do everything. He's only one person, unless we invent cloning technology. Boy, that would be awesome to have a clone. They could do chores for me, but I digress. I want to end here with some very good news. Is memberships are going very well. We are still at our second highest membership level ever. The all-time high is 179, which of course occurred in 2017. I should mention though that we technically did have 199 memberships at one time, but we gave away like 70 of those during the International Year of Astronomy when we gave away the Galileo scope. So those weren't paid members, and I technically don't count that. So, but currently we are at 171 memberships. I try to look around to other clubs in the state, and I'm as far as like the GR AAA, you know, the Grand Rapids Club, because they're pretty good size. There's the Ford Astronomy Club. There's the Warren Club. Those are all some of the bigger clubs in the state. We are roughly twice the size of most of those. So I think I'm not sure about like the University of Lowbrow Astronomers, because you know, talking about great websites. No offense if there's some lowbrows here, especially the webmaster. That site is really hard to navigate. So I don't know how many memberships they have, but I'm pretty sure we are the biggest club in the state of Michigan. You know, we're definitely the oldest, but I'm pretty sure we're the biggest, and it's thanks to all of you. So I really appreciate everyone for sticking with us. At least those of you that have stuck with us or returned over the years, like Dick and Jackie Gillespie. And of course, Pete Mumbauer recently came back, although Pete never traveled that far away. He could have stuck around, but he didn't.
Hey, Granville's where all the snow is.
Yeah.
Grand Rapids.
Well, of course, I should mention Pete earlier. You asked a silly question. You know, of course, with a C5, you can see galaxies that are 30th magnitude. You know that, Pete.
Shh, that was my secret. Don't let it out.
The C5 is the most amazing telescope ever built.
Yes, it is. I hate you, Mike.
The Hubble Space Telescope on the basis sitting on the surface of the Earth.
That is an inside joke. Maybe sometime I'll share it with the rest of you, but we'll save that for later. All right, so I did send out an email to everyone that needs to renew on October 26th. So if you did get an email from me to renew and haven't done so, please renew. I did just check my email earlier and did see that Frank Severance renewed. So thank you, Frank. And so if you're not sure if you have to renew, number one, if you didn't get an email from me, you don't. But pretty soon here, I'll try to send out my kind of annual email that says, you know, do nothing now, you know, membership in good standing, don't renew. Because, for example, oh, there he is, Arya, he is a repeat offender. I think every year he joins for 2 years, every year. Like, Arya, do not renew until I tell you to renew, okay? So far, I think Arya is currently good through 2023. He's getting a lifetime membership the hard way. And finally, of course, if you the best way to renew right now is online. But you can mail in your dues the old-fashioned way. But of course, do not send it to Kamsey. Mike does not get there very often now. And because he's currently in his classroom, right?
Well, now wait a minute. I'm usually at Campsie 2 days a week, so I can check mail typically Thursday and Friday, or Wednesday and Thursday. So I am checking mail more often. In fact, Dawn, I just sent you two memberships. Richard has both of them already on names and stuff, but I just sent them to you in the mail, so you should get those in a few days.
Okay.
He said Richard's already got his. Good.
Okay, but of course things could shut down again at any time. So I did include in the email my home address, So I hope none of you are the new Unabomber, otherwise I'm in big trouble. But just go ahead and send me your dues directly to me, because that way I won't have to travel to Kamsey, get those Kamsey germs, and or go to Mike's house and get those Sinclair germs and stuff like that. So
He'll dress up.
Germs? I don't have. Wait a minute. I have a mask. I have a mask.
That thing spews germs.
No. It keeps them all in. And I have a hood to protect my eyes from germs.
You need that to yield the power of the C5.
Yes, that's right.
Richard,
This is
who is that mask
This is
man?
my modified C5.
You don't need to know who that masked man is. It's better you don't know. All right, so that's the end of the president's report. Please hold your applause. Okay, thank you. So moving on, anybody want to share any observing reports? Anybody get out and observe? Jack?
I've been out just eyeballing Jupiter, Saturn, Mars, seen Venus a couple of mornings. I've had at least one person call me on the phone one night and say, "What's that bright thing near the moon?" And so I walked out the front door and explained to them that that was Jupiter, and they could see Saturn, and if they turned to their left a little bit, they could also see Mars. So it's been kind of fun sharing that with people. It's nice to see that stuff in the sky right now.
Unfortunately, we didn't have a Halloween full moon. We couldn't, at least I couldn't never see it. Or no, it was actually clear that night. No, I think I did see it. I can't remember now.
It was clear that night.
Okay, that's right. Yeah. Kevin took a picture, right? You took a picture. Arya?
Are there any sunspots developing now? Yesterday I looked at it and there were some sunspots.
Yes, there is. Let me, I'll bring up space weather here real quick and click on the current sunspot picture. And I'll share my screen.
I took a picture yesterday.
We'll zoom in there. Look at them. I forgot what they look like.
Yeah,
sunspots.
Wow.
Yep.
Quite large, too. Thanks for the heads up, Arya.
If I had a C5 on a solar filter, it would look bigger than that.
Oh, that'd take your head clean off, Mike. You got to be careful, even with a solar filter.
Hey, Rich, I got
that one today. It looked just like that.
Hey, Rich, I got an image to share.
Okay.
Not with a C5 though. It's kind of crap. It's kind of
darn.
crappy. Hold on, I got to figure out this technology.
You're only in IT. That's
Richard, I have a question.
Sure, go ahead, Jackie.
Wasn't there something supposed to happen on the 7th of the month? One of the planets in front of the sun?
No, there's definitely not a transit tomorrow.
No?
We would know about that for sure. Nothing that I know of, no.
I thought I read something about it. Sorry.
There was a transit of Mercury maybe a year or two ago in November, because they occur in either May or November, I think. Yeah, but no, nothing. No transit of Mercury tomorrow. In fact, there's not one for a while. All right, okay. Pete, go ahead and amaze us. Go ahead, Pete. Whoa, we lost it, Pete.
What? What happened?
Show it again.
You hit the wrong button, genius.
Did I? Oh, sorry.
Show the picture. It was up for a second.
My bad. Here we go. You see that?
There we go.
God, I hate you.
You suck.
Just hate you.
That was with my 8-inch f4 Newtonian. I finally dug it out of the mothballs after literally probably 15 years. So all sorts of cool little stuff.
What's the specs on this?
The specs. Okay. Good thing AstroBin has all that stuff for me. This is 6.7 hours of exposure through a red, green, and blue filter and illuminance. 8-inch f4 Newtonian. Auto-guided, taking over 3 nights. I just kind of started up with Sequence Generator Pro and go to sleep. So there's all sorts of little tiny ICs and NGCs in here. It's a pretty cool galaxy. I love M33.
I agree.
Mike, I say we wait outside Pete's house and jump him and beat him up.
I agree, man. I'm just gonna wail on him because this is I hate him.
I need to get dibs on his equipment once you guys are done with him.
I get his C5.
We'll wait until he gets the new mount.
Yeah, it's gonna be if that ever happens.
You gonna put that C5 on that mount?
All right. Any other observing or imaging? Of course, we're not supposed to have imaging. That's supposed to come once a year. That's okay. That's fine. Anybody else have any observing or images to share?
I did the same thing as Jack. I was out looking at Mars, Jupiter, and Saturn on Wednesday night for a little bit.
Cool.
Yep.
All right. So anybody else? I can't see everyone at once. So if I can't see you, I don't know if you have anything, but if not, we'll move on. So astronomical news and events. Of course, Osiris Rex touched down on Bennu and collected apparently too many samples.
What?
But somehow they got the lid closed. So it was so successful for a while there, they couldn't close the lid. Wow. But apparently they did. They did not make any other attempts to collect samples, and they're on their way back to Earth. And they'll land in Mike's backyard, and he'll keep it.
I'm keeping it all.
SpaceX has got their Starlink system up and running now.
Can I check that? Can I see if I can connect to the internet with Starlink on my system, my computer here? I don't see it.
That's how you get to AOL.
Yeah.
I will say there's a lot of stuff online in some of the astronomy forums that are talking about, the Starlinks the mega constellations are gonna ruin the night sky for astronomers, and it's probably definitely is true. But out of the hundreds of hours I've imaged this year, I've yet to get one of those satellites through my frame.
I have.
You have?
Yes, four with the 4 satellites going parallel with the Orion Nebula. It's almost routine too. It's almost routine.
The Finnish system is 40,000 satellites.
Mm-hmm.
Oh wow! Yeah, they got like what 600-700 up now.
Yeah.
It's a matter of time, I guess. I guess I can't take pictures of Orion now. Sorry.
There was supposed to be a possible collision between 2 satellites, as I recall, but apparently they missed. So we almost had a scenario with what's that movie called with Sandra Bullock? Gravity. We almost had one of those situations.
Gravity.
There was a guy who took pictures of Comet Neowise back in July who whined and complained online because all the Starlink satellites ruined his picture. And he posted a picture, and every photographer who'd ever shot at night, including me, kind of let him have it because nobody else had gotten their pictures ruined that bad. And we all accused him of manipulating the image.
Yeah. I will say I haven't seen a Starlink in any of my pictures, but I stacked so many images that the statistical averaging and combinations get rid of everything anyway. So math for the win.
I guess as long as you can get several good to every one bad, you're still okay. That's what you're saying.
Any other news?
Arya had his hand up.
Arya?
This is not related to astronomy, but what is that? China was developing something equivalent to GPS system on their own, which has better resolution also.
There's several countries that are doing the same thing. Europe's doing one. The United States is upgrading to GPS Plus. China's got one. Seems to me I read somewhere that Russia is in the process of building their own GPS system. So it's just because the United States has control of the main system, and they're all trying to come up with their own versions of this thing. So
China put the last satellite to complete their network, I think.
Yep.
They have a mission to the moon that they're going to pick up some rocks and bring it back. At least that's the plan, which would be the first return of moon rocks since 1970. So we'll see if that actually works. So the last time a country tried to do that, they crashed. So much for that.
Yeah,
we'll see.
The Russian system's called GLONASS, and the European is called Galileo. My running watch actually uses all 3 systems. The Russian one isn't really all that great.
Yeah. For those of you who have Netflix, I haven't been really keeping up on shows that come out on Netflix, but there is a 4 or 5 part series on Challenger's final flight. And
I saw that.
Yeah, that is absolutely amazing to watch that. A lot of behind the scenes stuff, but boy, the NASA decision making was non-existent, and it's definitely worth watching if you want to see, some of the issues with NASA prior to that launch.
Yep. Jack?
SpaceX be launching their Dragon Crew 1 next week. It arrived at the Kennedy Space Center today or yesterday. The crew arrives on Sunday to prep for launch next week. So that's a new step forward with things that we're getting back to normal from the United States, launching our own people.
Great.
I believe that's the 14th.
Yes, I think it is.
I did see that there was a full analysis of Kepler data, and they estimate there are 300 million Earth-sized planets in the habitable zone of sun-like stars in our galaxy alone. I think I saw that on the news that said there are 300 Earths, but that doesn't necessarily mean they're Earth-like, with the oceans and the nice nitrogen oxygen atmosphere. But that's from the Kepler Space Telescope. So that's all the news I can think of off the top of my head. Any other news anybody wanted to share?
Mars Perseverance is halfway to Mars.
Yes.
Still on schedule for February 18th landing.
Yeah. I thought about maybe we could do like a Zoom watch party, but I don't know if that would be something we could really, it'd be hard to see people and watch the landing, at least for those of us that are poor and only have like one monitor, although I could hook up my computer to the TV. That's something you can do too. So I can turn my TV into a giant monitor. So I don't know if someone wanted to.
How do you think I'm doing this meeting?
But if anybody wanted to potentially do like a watch party and join, I have no idea what time it's going to happen. So if it's like 3 o'clock in the morning, I don't want to see you people at 3 o'clock in the morning. Outside I would because it's dark, but in a fully lit room,
I can look it up and let you know.
Okay.
Hey, Richard, on your lecture series coming up, I've shared that on Facebook to people and had some people comment that they were interested. I don't know if they'll actually sign up or not, but
yeah, they always say that. Well,
yeah, but a couple of them are friends that are always checking out and commenting about astronomy things. So,
well, I hope so. That'd be awesome.
They will.
Make sure you plug the class too, because Richard likes money.
Well, that's one I think you had up on Facebook. Something I recopied and shared that.
Okay. Yeah, I don't think we've had it on Facebook yet, but we're working on it. All right. Any other current events? Nothing? All right. Moving on here is, of course, we were supposed to have our first online viewing session of the season tomorrow, but the winds are supposed to be sustained at 20 plus miles per hour with gusts potentially higher. And of course, we know from experience, because we had this member we don't talk about, that when we took our trip out west, the winds got really high. This high weed tumbleweed came by and took the guy's head clean off, and we buried him out in the desert somewhere. No, but we don't talk about that. So those tumbleweeds are deadly when they get moving. So we're going to postpone to next Saturday. Right now, the forecast looks a lot better, and I know some people said, well, that's 7 days away, Richard, or 8 days away. But the forecast has been for high winds out west all week long. So right now the winds are supposed to be next week 5-6 miles per hour or something like that. With clear skies, we won't have trouble with the moon. I don't think we would have had trouble with it yesterday because the session is only 2 hours. But hope you all join us. It should be a lot of fun. We currently have over 80 registrations. And as I mentioned, there are roughly 40 people on the online viewing session email list, which is for non-members, to join in. And a lot of those haven't registered yet. So we should have hopefully a good turnout, even if roughly, half of them turn out, we should have maybe 50 plus people. But just to remember, we can only have 100 people on Zoom. We could pay to let more people on, but I think 100 on Zoom is plenty. So if you can't get on Zoom, make sure you go to our YouTube channel, which I'll have a link for. It's on Twitter right now for the live stream here, but you can go to YouTube as well if you can't get in the Zoom meeting. And I'll have a link for that in a reminder email next week. So I'm really looking forward to doing the online viewing sessions. Last year we did the remote viewing sessions, but in person at Western. That was never the way I wanted to do them because, yeah, it was fun. We got to get together, but back in those days, we used to get together all the time, right? With meetings and observing. So this is where, people from technically all over the planet can participate. And so that's why I went to great lengths to contact so many different clubs to invite people. So I've heard from a lot of people from a lot of different clubs. It's been really fun chatting with some of them. And I'm hoping for kind of like an online star party type experience. And so, so hopefully it'll be a lot of fun. So if you haven't registered for the session, which will now be on the 14th, be sure to do so. So don't miss out. We do have a board meeting.
Richard, do we have to re-register or?
No, you do not.
Okay.
Did everyone receive an email from Zoom today that the session was rescheduled?
Yep.
You should have. Okay.
Yes, we did.
So that means you're still registered. If you want, you can just register again, but it won't do anything because it won't add you twice. I've seen some people re-register even though they're already on the list, but that's totally fine. So, if you have any doubts, don't worry about it. But if you did get that email from Zoom, you should be good to go. So don't worry about that. Unfortunately, I couldn't put in like a little note that says why we rescheduled the meeting, but hopefully most of you figured it out that we couldn't do it. But I did mention in the email yesterday that we were going to have high-speed winds and all that sort of thing. So hopefully it won't come as a surprise to anyone. Did anybody else have something to mention? I thought there was somebody else too.
Richard, I was just going to say I looked it up, and Perseverance lands February 18th at 3:30 in the afternoon, our time.
Okay. What day of the week is that?
Thursday.
Okay.
February 18th.
Okay. So we could think about it. All righty. So next, we do have a board meeting this Sunday. That'll be 5 o'clock on Zoom. Of course, usually just board members attend. But if you want to join in, feel free. Maybe you're thinking about running for the board next year, and you want to see what it's like. So you can see how a board meeting goes. Maybe Jack and I will scream at each other. It's happened a few times. It's always fun.
Has my ban been lifted? Am I allowed to do it again?
Are you banned?
Was I?
I don't. There's only one person I could think of that was banned, and he's dead. Thank God.
Long gone.
So
the tumbleweed guy.
So you can, yeah, I wish. So you can zoom in if you want. So just let me know, and I'll send you. Someone the link or the necessary info to zoom into the board meeting. So moving on. Well, they should be short too. Board meetings have not been very long. Most have been under an hour recently, just because there's no outreach to organize, because that's all gone right now. So it actually won't be very long at all. There's frankly not that much to talk about. All major projects are done. So we're good to go for a while. Moving on, Prime Focus, always looking for articles. Trying to make maybe the December issue is, that'll be the last issue of Prime Focus's 50th year. So if anyone wants to maybe send something a little fun, I know Kevin had an article in mind that would be lovely to get. So I know I've been meaning to talk to Aaron. I know Aaron does a lot of sketches. One day we maybe at least want an article on sketching, but maybe even a little presentation someday. But so that's something to keep in mind. People can share imaging techniques like Pete.
How to make flat fields.
There you go. I was bugging him about that recently.
Yeah, I'll write that article.
Okay.
Writing it down.
All right. And again, the usual deadline is the 15th of every month. Anything else anybody wanted to mention? Jack?
Richard, we'd like to have a picture of your plaque online somewhere, whether in the gallery or somewhere on the website. It's well deserved, and it should be posted there. Well,
you want
there, but I want a picture on the website.
Do you want just a picture of the plaque, or can I be in the picture too?
Oh yeah, like that, like that.
I gotta figure out where to put it. It's actually very nice. I gotta show it to everyone. They really did a nice job with this. They even spelled my name correctly and everything. That's what's nice about having a really boring name like Richard Bell. It's easy to spell. Anybody have anything else? Alrighty. Last thing, let me go back to my screen sharing here and see if I can, just because I want to make it a little fancy here. So back up here. This is our next presentation. Of course, normally in the December meeting is the annual meeting. I guess it still technically is, but it'll be a little different than usual. No holiday party. We were going to retool that anyway. We were going to do like a winter solstice dinner at a restaurant somewhere, but of course we can't do that either.
Oh, bingo?
Yeah, no bingo.
Oh.
So we'll have to give bingo a rest for a year. I'll find some surprise or find some prize to give you, Mike. I'll drop something off on the yard, but unfortunately I don't have a dog anymore, so I can't make it the prize that I want. I can't give you a flaming bag of poo.
Hey,
Yeah.
Richard.
Yeah.
I don't know about prizes, but you could do online. We could do online bingo.
I tried to find something. I didn't see anything.
Oh, you just have your little wheel there, and you go B5.
What I did? I got a mail.
Yeah,
I got to mail bingo cards to everyone.
Bingo. Where's my prize?
That'll give at least Sinclair an opportunity to win in his mind anyway.
Well, I already have this plan, so this is what we're doing. We're not going to do bingo. We're going to give bingo a rest. I think that's probably not a bad thing anyway. We've been doing it for 20 years. It's time to maybe give it a rest anyway. So that's one thing about the pandemic, is it's given us a little respite from doing some of the same things over and over again.
But
Even though it is.
I've never done that.
Well, that's your problem. So this is going to be our guest speaker. I was surprised she accepted the invitation. So this is Dr. Emily Levesque. She recently wrote a book called The Last Stargazer. So her talk is basically based on that book. I do not have a copy yet. My niece is always looking for gifts to give me for Christmas. So this will be the gift I'll tell her to get me. But I probably won't get it till Christmas. So. And of course, we can't have her sign it because she's, of course, not here. But she'll be giving this presentation, and I'm really looking forward to it. So again, this is where I'm trying to make turn a disadvantage into an advantage, and because otherwise it would be very expensive for us to bring her in. And so this will be our presentation for the December meeting. And if there are any other kind of astronomers out there that you might think you might want to speak at future meetings, just let me know. But you guys know me. I already have kind of people in mind for January, February, and March, and the April, May people I'm going to basically invite from the people that were supposed to speak last year. So if we can meet in person, they'll be able to come meet us in person. But if not, we'll just do it all by Zoom. I know I don't want to be on Zoom forever, but we're doing our best here. Yeah, Kevin.
Richard, you should have the information about the January speaker in the next week or so.
Yoo-hoo! We'll keep that secret for now. We won't tell them who it is.
Okay.
I am going to have you do the intro to that too, by the way, Kevin, since you know him.
Oh, really?
Yes. I know it's news to you, right? But it just makes sense.
Well, just because I've known him since we were kids.
That'd be one thing, yeah. The last thing I was going to mention, just to see if anyone's interested. Of course, you have to live in the area, but it is clear So if anybody wanted to run out to Owl Observatory and do a little viewing, we could do that. If you haven't seen Mars yet and want to see Mars,
You're talking about tomorrow, right?
No, tonight.
Oh.
We could do it tomorrow as well, but frankly, I had planned on going out and doing some imaging tomorrow.
I actually think tonight was supposed to be a better night anyway.
Yeah. So if anyone had any interest in doing any observing after the meeting, we used to do that in the good old days, but we don't do that much anymore. So looks like everyone seems to be locked in for the night. So,
so you say you're going?
I tried.
Hey, wait, you're not off this yet. You say you're going? Really?
If other people go, sure.
I'm in.
Okay. I can meet you out there because frankly, I am sick to death of John King and his magic wall. I don't care anymore. Okay, so anybody have anything else before we sign off here? Nothing?
Hey, Jack, stick around just for a minute.
Oh, so we'll kind of conclude the meeting here officially, but